Okay, so you have a set of problems here called not technically, and we're going to take a look at those and see how to do them. The first three questions you should be pretty familiar with. In each of these sections, they're kind of repetition over things that we've done in the past. The last question is the one where we're looking at the conclusion, we're writing it in non-technical terms. So let's look at number one. In problem number one, the claim is Eric claims that the mean SAT score for his school is 1160. So this is a quantitative claim. So we're making a claim about a mean. So we need a null and an alternate hypothesis. It is a claim of equivalence. So the null hypothesis is going to be that the mean is 1160, and that the alternate hypothesis is that it is non-equal to 1160. Okay. The second question asks, is this left, right, or two-tailed? Since it's a non-equal statement, this is still a two-tailed test. Okay. Part C of the problem says, so we get this additional information. Eric collects the SAT scores of 50 of his classmates through a simple random sample. He finds that the mean score of the population must be between 1156.6 and 1159.4. So the top end of that interval is 1159.4, and 1160 is bigger than the top end of that interval, 1159.4. So there's no way that the null hypothesis can be true given that sample. So we reject the null hypothesis. Now keep in mind, in this example, the null hypothesis is the claim. So we would say that the sample does not support the claim that average SAT is 1160, okay, because the null hypothesis, which is the claim that the average is 1160, has been rejected. So we say that the sample, there we go, the sample does not support that claim that the average SAT is 1160. All right, so that's problem number one. All right, looking at problem number two, we have that Abby is claiming that more than 50% of her classmates own a dog. All right, so this is a qualitative claim. So we have a null and an alternate hypothesis. These are going to be about a proportion. The null is always the equivalence statement, so that's going to be that the null is 50%. The alternate here is going to be our claim, which is that more than 50%, right? So keep in mind that this one is the claim. All right, so part B, so this is this left-tailed, two-tailed, or right-tailed. This would be a right-tailed test because we are greater than in the alternate hypothesis. Part C, we have some additional information. Abby takes a simple random sample of 45 of her classmates and learns that the actual percentage of her classmates that owns dogs has to be between 41 and 70. So this proportion of 50% is between 41 and 70. So here we fail to reject the null hypothesis, because given that data, the null hypothesis could be true. Now, the null hypothesis is not our claim. So if the null hypothesis can be true, then our claim could be false. So remember, the claim here is represented by the alternate hypothesis. So we would say that this sample, or the data, right? The sample does not support the claim that 50% more than, the claim is that more than 50% of classmates own a dog. So her claim could in fact be false given that sample. All right, so we'll take a look at problem number 3. All right, so let's take a look at problem 3. Problem 3 says that Gene claims that his school cafeteria serves some version of squash more than 30% of the time. All right, so in problem number 3, we do have a qualitative claim, so we need a null and an alternate hypothesis. This is going to be a claim about a proportion. The null hypothesis is an equivalence statement, so that's going to be exactly 30%. The alternate hypothesis here is my claim that we are more than 30%. So note, this is my claim, right? Part B, since the claim is greater than statement, this is a right-tailed test. Okay. Part C, should Gene, we have more information here. Gene records the cafeteria's offerings for the next 50 school days and finds that the actual proportion of days that the cafeteria serves squash must be between 68.9 and 91.9%. Well, 30% is definitely lower than 68.9, so we can reject the null hypothesis, because this can not be true if it has to be between 68.9 and 91.1. But note, rejecting the null actually supports the claim, because the claim is that it's greater than 30%. So this sample actually does support the claim that more than 30%, not 0.3, but 30% of sample supports the claim that more than 30% of the time the cafeteria serves squash. Okay, so since we rejected the null and the alternate is the claim, this sample actually does support the claim. All right, so there we go. Okay, so let's look at problem number 4. Okay, so in problem number 4, we have that Karen claims that a person who goes to Chipotle spends on average $11. Okay, so this is a quantitative claim. So in this problem, we have both a null and an alternate hypothesis. We're claiming that they do spend 11, which means that the alternate would be that they don't spend 11. Okay, so note, our claim in this case is the null hypothesis. Okay, so what we need to do is determine the type of test. This is going to be a two-tailed test because this is a not equal in the alternate hypothesis. So we get this additional information. Karen takes a simple random sample of 400 Chipotle orders and finds that the actual average expense per person is between $10.95 and $11.05, which is great because $10.95 is less than 11, which is less than $11.05, which means that I fail to reject H null. Okay, so H null was the claim here. So we can say that the sample in this case here supports the claim that the average amount spent at Chipotle is $11. Okay, so there you have it. Again, if you have questions, make sure you come to the drop-by session that's in the email. But there's your answers about writing claims in non-technical forms, and we'll go from there. Thank you.